So good afternoon, everybody. We hope you all have been having a great time at KubeCon. We really appreciate you taking the time to come to our talk today. A lot of great options, so thanks for being here. I'm JP. I'm on the compute runtime team at Netflix.
Hello, hello, hello. We hope it's like 3 p.m. We hope you have not cubed out yet. And is anybody coming from our control plane talk just 15 minutes ago? Raise your hands. Oh, awesome, a lot of people. I'm Artem. I also work together with JP on the compute runtime team. And if you look at the top of our slide, we have this screenshot from the movie Fight Club, and the soundtrack to which is called Where Is My Mind. That's kind of inspired us to name our talk, Where Is My Pod? Where is my... Anyway, let's get actually started.
All right, so our hope for this talk is actually that you just come away with some ideas for how observability, specifically tracing, can improve not only your ability, but also your end user's ability to answer that just never-ending question, like what happened, right? We get it all day, probably every day. And so for our team, this kind of journey really began at the beginning of the year when we started we're going to adopt Kubernetes, right? That might sound weird, we've been running Kubernetes for a while, but specifically we're talking about the kubelet, right? So the data plane side of the system. And so at the beginning of the year, we had a plan to migrate all containers at Netflix from the current runtime to this new runtime, and we want to use a standard software, standard components. But one of the most critical aspects we kind of had to answer is like, what's the impact to users, right? At the end of the day, migrations are really going to live or die by whether or not your users are happy. So early on, we saw the need to confidently answer the customer questions of like, they experienced something and it didn't match their expectations, right? It's like reality is not matching up with what they're used to. And so we also knew we wanted to show off improvements, right? It's like migrations, it's like should be better, right? You should be in a better place at the end. So once we began this migration, it became pretty clear we needed to be able to answer the questions, and we were going to lean into observability to do that, right? The other question was if a workload isn't working, we kind of had to know soon. We could flag it, delay migrating it later. And at the end of this month, we're actually going to go from like 0% to 100% by the end of this month, just within about a 6-month period. And along the way, we've actually gained a lot of customer confidence from this, which has actually been really exciting for the team.
And to add a little bit more color to this story, we're going to show some case studies of where we, even after the migration, we have been continuously extracting value and debugging issues faster and just making things better for everybody. And we hope that's going to be useful to you, most importantly. So with that, let's get actually started, starting with the history of container orchestration at Netflix. Introducing Titus. Some of you might already know from the previous talk on the control plane, Titus is our container orchestration and management platform. So at this moment, and any other moment, in fact, it's running hundreds of thousands of pods across many regions of this beautiful planet. And it kind of does all kinds of workloads at Netflix so for example, the recommendation systems that we're kind of known for, encoding workloads, log ingestion, data ingestion, content engineering related things, live events, more recently than other things. And it was started about 10 years ago in the early days of cloud native, when Kubernetes hasn't yet won the orchestration wars. And it was based on Apache Mesos. And then in 2018, so a little bit later, we have migrated the control plane specifically to be the one based on Kubernetes, as you've just heard. But we left kind of the data plane intact, as JP said, until the start of this year. And we then had this migration. And given the scale of what I just described and the variety of workloads, you might expect that the architecture is very complex. You're right, that's what it is. And this is just a sort of overview. We're not going to go into all components. We just don't have time. We are going to specifically double-click into the data plane aspect of it. So here we have kind of almost a fully custom data plane where we have a few key components, starting with virtual kubelet, which is an open source kubelet implementation that masquerades the node as a kubelet node and allows you to link your clusters to kind of custom hooks and other functions, right? And then this would feed into systemd. It's running on the host, so nothing unexpected here. then maybe the main element on this picture is this component called Titus executor, which is based on the Mesos executor originally, and it's kind of everything about container lifecycle management. So start a container, allocate resources, then clean up, and everything in between, right? And naturally, it would call into our custom CNI to get an IP address. It would call into our custom CPU isolation service to allocate CPUs. And then it would kind of assemble it all together and then call it to Docker. Docker would pull an image from our container registry, then assemble all of this together, and then send it to containerd, which would then, it's not shown in this picture, but it's going to send it to runc. So the main point of the slide is that it was kind of a fully a custom data plane implemented over the years. So we kind of knew how everything works, more or less, and the challenge, of course, of this is that it's hard to maintain, it's hard to upgrade all the time, and it's just a big code base, or in fact, it's multiple code bases. And we, at some point, we just saw that there is like a lot of things are just not that differentiated from what is available in the kubelet-based data plane, right? So we were like, let's do this migration. And JP, do you want to talk to us about like the new data plane, how it looks like, and how it's better, or how it's different?
So we call it real kubelet internally to everyone else here.
Kubelet.
It's just kubelet, right? The thing you've always kind of probably known. So aside from hopefully we feel like the migration, we also have better diagrams. But one of the benefits from adopting real kubelet is we're actually excited to be able to contribute back to the community, get involved in all the different repos. Specifically, we've been working a lot with the containerd team, and that's been really exciting. And as Artem was alluding to, we're moving from a system where the large majority of the software we wrote internally, right? So we have years of operational experience with it. We know where it's going to fail. We know where it's, kind of where the bodies are buried, so to speak, right? As we're basically adopting all these new components, some of them, us on the team, we have some experience running it, maybe not at this scale yet. And so early on, we knew we were going to be needing to lean into observability to be able to give us those quick picture and gain a full understanding of like what is actually happening when a pod is created on these nodes. So for me, I've always loved in reading those the articles, the deep dives of like what happened when, right? I assume that's going to start. So this kind of is a good example of like, this is everything that happens when a pod is scheduled on a node, right? Or is actually kubelets taking over. You're going to see all the interactions with containerd, all the interactions with our NRI plugin, and we've even instrumented more and more parts of the system from our registry, OCI hooks, CNI, really try to give us that full picture of like what exactly is going on behind the scenes when we're running a customer workload, and more importantly, like where are things failing, how long are they taking, and so that really gave us like a full picture.
So you might ask yourself now, like, why is this not my standard observability? Like, why did I come to this talk, right? And that's a valid question. Here's kind of the answer. On the left, we have the happy path. Hopefully, you like the Happy Gilmore movie. The happy path, it looks like a synchronous API request, and you can kind of things run in the same execution context, and you kind of in real time create this trace waterfall, and you then just inspect it, right? So that's all great and good. And we do that too, but we also do more than that. We also have this uncharted territory, which is we instrument a lot of things across different execution contexts, and then we, and the important thing is that those can run asynchronously or at different timestamps, and we then on the back end we join and recreate all of this sequencing asynchronously, right? So we have this like as a result we have this like end-to-end tracing across multiple components that are like not necessarily sequential, right? And that's kind of the real thing we're doing here, right? And and to be more specific, we have kind of two main ways of how we are achieving that, right? So for the same execution context, we have what's called propagation. So we can do this either via standard propagation or via environmental variables. And that's useful when things run on the same instance, for example. And so an example here would be, kubelet talks to containerd, talks to runc, OCI hooks. And this just happens, sequentially things wait on each other. It's all clear. Same goes for our custom CNI, for our CPU isolation service, and so on. And then maybe the more interesting part is called the span links, right? So it's about having a trace, for example, for a given workload in a kube scheduler, and then having like a literal link icon and clicking on it and landing on a trace inside a runtime component for this. And then you can kind of imagine a link button and a back button in your browser, and you can kind of go back and forward very fast and like get additional data, and it's all kind of sequenced, and the timestamps are there. It's like all looking good, and you can very quickly even check a hypothesis, right, or something like that about what you're investigating. And even better, to make it even more end-to-end, we can expose this to our customers. So like, for example, a machine learning workload or a platform has their own custom code. They have an instrument in that as well, and they can connect it to our end-to-end tracing to make it more end-to-end. And this means like they can self-serve issues sometimes for themselves because they have access to all of this. And we can actually work on improving the platform itself instead of helping them like discover something that they would otherwise know as well. And we can like binary search sort of or narrow down the scope this way and so on. So to just summarize this kind of chapter of our talk, we had this mostly or fully custom data plane. It was well understood. It was written by ourselves, right? And then we migrated to this more upstream, more industry-aligned data plane. And it was less understood, and we had to ensure high reliability. We had to like resolve issues very quickly for our customers to have confidence in what we're doing. The challenge is we didn't really understand it, and we didn't even know like where to look for some latencies potentially or something like that. So that's why we kind of instrumented this. And now we're going to show you first of all where it was useful to us, and then some of the upstream fixes that we are doing right now or we already merged. So this kind of gave us an opportunity to start doing a lot of open source, go open source.
All right, so to kick it off, I'm going to talk about something that I've kind of started to call
who is this phantom span?
Right. I call it the phantom span, right? So it's like you were all, if you've seen a trace waterfall view, you're going through it, and every now and then you're going to see like an execution, and then like nothing is happening, which we know is not true, and then another span starts, and it says, okay, I'm done now, right? So I've gotten to call this the phantom span. So in this top image, you can see Containerd was updating the sandbox metadata. And then again, it updated again, but this all happened within like, there's a 2-second window in between that, and that almost encompasses the entire 2 seconds of actually running the pod sandbox. So thankfully, we had a little bit of a hint. As you see on the span a couple above, there's a little circle dot that gives us that's a span event. That's actually a Containerd log line that says like, here's the CNI result. So that kind of gave us a pretty good indication. Like again, if you've never looked at running the pod and what all is involved, you immediately can see, okay, CNI is probably involved here. And then the bottom one, honestly, we had no clue, right? This is like the NRI plugin. It's still fairly new. But what we did see was like, okay, the Containerd sent the task kill command, 9 seconds elapsed, and then a state change happened, right? And as far as we knew, like, we're not seeing anything in our code. Like the NRI spans aren't here. We're pretty confident that wasn't it. So yeah, at least this gave us a starting point. We could jump into the code, look for where the task kill span is started, and sort of follow the execution flow to where the state change RPC happened. So for that first one, we've actually instrumented CNI. So we are relying on OTEP 258, which is environment variable context propagation. So what we've done is in the CNI library in Containerd, we're starting the spans there, and then when it actually execs the binary, it takes the trace context, adds it as an environment variable before it actually execs it. And so that allowed us to, in our CNI implementation, we can then pull that trace context out and continue basically the trace flow view. And what we already have right now, we've got the binary, which we call Itman CNI, and then also on the host, we have the Itman agent. And one of the next things we're going to be able to do, because you still see we've got this pretty long 2-second span going on, that's actually where we're doing a remote RPC call to like an Itman service to actually do the IP allocation. It's probably going to be maybe talking to AWS to allocate the IPs. So again, this just gives us that full picture of like, where is all of this time getting spent? And for this change, we've actually just recently pushed up these 2 changes. Feel free to check them out if you want to, if you're comfortable If you can and have the ability to apply some containerd patches to your infrastructure, you might be able to find some key you didn't know existed. So let's talk about that other one where we literally had no idea what was going on. So we instrumented a portion of containerd and a portion of the NRI library. And we had a pretty good idea. It looked like, hey, there's a mutex that's guarding, looks like every single operation that happens in NRI, regardless of pod, right? So if you're stopping one pod and you're trying to create another one, that create opRec will not even begin until the stop is finished. If you're going to go hear a talk later, you're going to go see Eric, our colleague Erickson's talk, talking about the details of NRI and why sometimes we take a little bit longer to do things. But more importantly, this kind of started to give us a hint of like, okay, this is behavior we weren't expecting. We didn't really know that this was going to happen. But how impactful is it, right? So at this point, we can start to ask questions of our data. We're doing more analysis. We're able to kind of group by all of these spans. And as you can see, the NRI lock is actually pretty expensive, right? It's taking a considerable amount of time. And where we were starting to see this happen is when we would run integration tests. They would just sort of randomly fail because it took too long to run. And so we knew we were going to have to fix this to continue the migration, right? So we couldn't have worse latency after customers migrated. So what we've done is we have an implementation. We pushed it up recently. We're excited to kind of work with the containerd community to figure out, like, is this the best solution for now, or is there a better one, and kind of get that done. And then this last one is the one that I want to talk about. It's really different. So it's the what we call synthetic traces. I assume it's going to start. All right, well, maybe it'll start. There it goes. All right, so the synthetic trace. So we talked about execution boundaries, and in this case, we've got our Titus API. That's one execution boundary, and then we have the scheduler. That's another one, and then we actually have like the data plane, the kubelet. We really want to be able to get like a full picture of what all is happening at each step along the way. And so what we were able to do is our Titus API, which is kind of like a Kubernetes controller in some ways. It sees a state change that, okay, a workload has started. At that point, it's going to take all the information that it has on the pod, which is in annotations. We inject timestamps. We inject the trace context along the different paths. It's also going to take its state metadata, and then it's actually going to build a synthetic trace to give us all of those execution boundaries. I'm going to jump back and forth once. And so what you can see here towards the end, we actually create span links. So if we wanted to jump to the scheduling execution trace, we can do that with the green bar. Or if we want to jump to the data plane execution trace, we can actually just click the link, and we're now jumping straight into like, okay, this was the syncPod trace for this execution. And more importantly, these synthetic traces are driving our SLOs. So we've added all of the attributes we wanted so that we can construct good, rich SLIs, and then for the first time, we're actually able to start guaranteeing some SLOs for our customers, launch latency, error budget, pod launch errors, and we've got a lot more coming for that. So this last one is one Artem's going to tell us about, was actually kind of recent.
It's a juicy bug. Time for a juicy bug. Okay, so I was actually on call just a couple of weeks ago, so it's a true story. And I get a message from our partner in machine learning team, and they just build a platform on top of Titus. So they submit most GPU workloads to Titus, and we run it for them. Okay, great. So their issue is like roughly as follows. They submitted a workload. It failed to start. Then about an hour later, they also submitted the same workload as they claim. And it was routed to the same exact instance, and it succeeded. And it's like, okay, and by the way, the top trace is the failed one. The bottom one is the successful one. And they are asking us, can you investigate what's going on and tell us why it's happening? And rightfully so, they are assuming it's an infrastructure issue, some like intermittent error. Well, because
we couldn't blame DNS.
At the end of the day, it succeeded, right? So everything's like great. And we obviously want to fix it because it might happen in the future if we don't fix it, and it's all of the stuff is costly. It's GPU related. It's all people are competing for things, so on. All right, so I go into our registry and I'm like, did you change your image? They say no. I'm like, are you sure? Okay. I didn't say that, but then I go in, I check the layer digest, and by the way, the log that I saw when I was like, is there an actual error? It was related to unpacking this layer 7.4 something, and I see that all the layers are the same across time, and there is no pushing activity at all for this image. So they were indeed correct. There was nothing changed. And then I look at the two traces and I start comparing them, like different attributes for this span. And I see that the size is the same. It ends in 339 or something. And the digest is the same, but the attentive observers right now are about to say, what about the media type? And that's correct. That's a good lead for the next slide. However, how is this possible that the image didn't change, but the media type is different across the two runs, right? So at this point, you're like, how do I answer this? And if you're trying to claim that it's not an infrastructure issue, you have to have some data or something to back up your claim, right? So you need to understand what's going on. Okay, luckily we have this tracing, and we were just, as JP said, we can ask questions of our data. So I go in and I say, okay, if it's related to unpacking, let's see at this node or at this instance where it happened, what was the unpacking activity related to this layer specifically, right? And oh my gosh, there is something at 130, which is unrelated because the failure was at 1, and then they started it again at 2 when it succeeded. So this 130 event was completely out of the picture for us and for them. So we were just unaware of what's going on. And if you reference it to the media type thing from the previous slide, you see that the color coding says that the tar plus gzip is actually a 130 event. So we were kind of completely missing this occurring on the same instance, right? And so what actually happened? Their colleague, who is using a very, very similar image with most layers being shared, but something a little bit different, they started their own workload on the same instance, which was routed to the same instance. And it had this layer with the same digest. It was just declared as different media type. So this layer was successfully pulled, it was unpacked, and cached, most importantly, cached on the instance. So it was stored for anybody else to use on that instance until the instance terminates. So when this second run at 2 p.m. was initiated, it picked up this layer. It didn't have to pull or unpack, because why would I waste effort if it's already there? It used it and just ran with it. Okay, and this is why their workload was actually started, not because something was fixed or because of some infrastructure issue. And it was basically masked, right? And if they started on some instance again that didn't have the layer, they would fail again. But this pool of instances they could start on is kind of small, so you could say probabilistically there might never be a case where they fail. So this bug would be carrying around sort of forever, and maybe nobody would fix it. But we gave them these findings, and if you're curious, they found a bug in their image building or publishing system called Bazel. I'm not an expert on this. And it was kind of selecting random or incorrect media types sometimes, or just no media types at all. And this was just out there in the open, right? And so now it's merged, as you can see, and now we kind of fix this for the whole world, so to say. And we were able to just very quickly find the issue, give it to them. They were like, wow, incredible. and they fixed it upstream.
No arguing. No arguing. They actually were like,
this is the best part.
Yeah, absolutely.
Okay, if you've been kind of checking TikTok or LinkedIn, now it's time to come back. This slide for you.
All right, so these just are high-level takeaways for today. So the biggest one is try various approaches when you're starting your instrumentation journey. If you've got exotic traces, there's a link to this. These are not your standard HTTP calls, right? It's it's not an API. It's calling maybe a database or a couple other microservices, and it's all done. You can kind of manage that execution context yourself. This is for cases where it's you've got maybe long-running jobs, async jobs. So for our scheduler, what we do is we try to schedule it. If it works, great. If it doesn't, we save that trace context, and on the next execution, we link back to it. So when we jump to the successful scheduling trace or an error scheduling trace, we can go back and forth to see okay, how many scheduling executions did this actually take? And then on that synthetic trace, we can actually see that full, how long did it take overall?
The second thing we would like to highlight is that from my example just now, you kind of never know when some attributes are going to be useful to you. So like the more you can pour into every span of the data that is relevant to it, the better, because sometime you will be able to group by it and you will surface some important issue. If you don't have that information, you might not be able to find something, just spend cycles on it. And if you have more of it, then it should be better long term. And if cost is the concern, it's a related point, right? Then you can self-host, Jaeger or some other open source tracing solution. You can also just control this universal toggle, which is the sampling probability. So you can sample everything with a certain rate, or you can go one level lower and sample important things with higher probability and less important things with lower probability to keep the costs under control effectively.
So the next one is phantom spans. I don't know if that's a trademark term now or not, but learn to recognize them, right? When you're looking at your trace waterfall views and things just start matching up, kind of learn to spot that over time. And then the next one is obviously once you see those phantom spans, get comfortable adding instrumentation. So hopefully you're in a place where you can actually apply changes to these, whether it's your software or if it's someone else's software. You've got a way to do patches and deploy those. Because auto instrumentation, it's only going to get you so far, right? So it's we had all of these spans, all this rich data just by enabling kubelet, enabling containerd, but it wasn't enough at the end of the day. We had to actually jump in, roll our sleeves up and actually do some instrumentation ourselves.
And we even think that adding this kind of instrumentation can become part of your standard, SDLC or software development lifecycle. Just how you write tests. You write tests, right? They're all great and they cover everything. Awesome. So in addition to that, you can do kind of, boilerplate almost tracing. And I think I've heard somebody 2 days ago in this conference saying that they wrote an AI agent that kind of adds boilerplate tracing to all of their PR to a certain repo. So you can kind of do things about it to minimize the upfront cost and still get the benefits that we went over.
Yeah, so the last one is, we didn't really get into it, but don't be afraid of sampling, right? It's if you talk to somebody about traces, that might be one of their first arguments against it is well, sampling's gonna, make me lose the things I care about. Invest in tail samplers. eBay actually gave a great talk earlier about how they are able to do sampling without having the memory overhead of tail samplers, so you should check that one out. So the last thing.
Yeah, with that, if you like observability, you want to chat with us, other people who are geeking out on it too, there's a reception later tonight at Miller Union. Sign up at booth number 14 something.
1450.
Yes,
Yep.
1450.
Okay. And next. Yeah, the honeycomb booth. Just if you don't remember the number, look for honeycomb.
Lastly, we want to invite you to an awesome talk where our stunning colleague Ericsson will go over very, very specifically how we use NRI, OCI hooks, and in general, the early part of our talk, the data plane migration and kind of what we did there specifically. Please check it out. That's the QR code. Maybe we should give folks a couple of seconds to scan it. Maybe you want to scan it.
All right.
Yeah, and with that, thank you very much for coming. We hope you learned something useful. If you have feedback for us, constructive or positive, we'll have both.
All feedback's good.
Yeah, please go ahead, submit. Or if you want to ask questions online instead of in person, please go ahead. And then lastly, if you like this stuff, if you want to work with us, if you are excited about all things observability and data planes and upstream and everything else, please consider applying. We have openings. We would love to